Okay, so I wanted to make a video to show some of the identities that are listed in the back of your book, or if you're using an ebook, they would be in section 5.3 in your book, I do believe. And there are a lot of them, probably 15 to 20 of them. If this was a seated class, I would probably have you memorize several of them, and then we go over generating the other ones, so you wouldn't necessarily have to memorize them. I'm aware that given that this is an online class, you don't necessarily have to memorize them because you'll always have your book or a printout of everything available when you're doing homework and when you're doing exams. So I figured I would derive one or two of them in this video, or it might take two videos because they take a while. And then we'll just look at some problems using the different formulas so you can see why they're useful and why we need to do them. So first off, one of the things that you will actually be deriving some of these yourself in your lab this week that's part of your homework, but I figured we would derive this one first. So last week we did the sum angle formula, and I have this one right here. I'm not going to derive all the formulas for sine and cosine and tangent and all of that. Again, you have them in your book. We'll restrict ourselves to just doing one or two of them, and then the form is always the same for the other formulas. So we have sine of x plus y equals sine x cosine y plus cosine x sine y, our sum angle formula. But one of the things we can do, and you'll see this in the lab you're going to do this week, let's just make y x. Then I get sine of x plus x is equal to, we'll now just replace the y's with x's, sine x cosine x plus cosine x sine x. On the left, I get sine x plus x, which is clearly just sine of 2x. On the right, I get sine x cosine x plus sine x cosine x, which is just 2 sine x cosine x. And there we go. And this is actually called a double angle formula, meaning this is sine x and cosine x, and I can use it to find sine of 2x, twice x. We don't necessarily need to do an example of this one. This one is pretty straightforward, and like I said, you'll work with this in your lab, so I'll leave you guys to mess around with that one. I'm not going to derive them here, even though we'll use it later in the video, but you can just as easily find cosine of 2x. That will be cosine of x plus x, and then apply the sum angle formula from last week with cosine x plus x. Apply the formula, combine it, and go from there. One thing I will point out, and again, I'm deliberately not doing this because I want you guys to work this out on your own, this one. It's in your book, but there's generally one form for the sine double angle formula, that one right there. The cosine double angle formula, your book, in the section or in the back of the book, usually gives 3 different formulas here for the cosine double angle formula. And we'll use different parts of that, meaning sometimes we'll use the first one your book lists, sometimes we'll use the second one. So you should at least familiarize yourselves with all 3, which is why I'm leaving it to you to derive them. They're not that hard, but I want you to algebraically manipulate them so you're familiar with them so you can use them to solve problems. And you can check yourself by just looking in your book and seeing if you're deriving them correctly. But that's the double angle formulas. They're pretty straightforward and direct, so we're going to kind of leave those there and maybe look at one problem and kind of see how this is used. And let's see, just so we're clear, we have sine of 2x equals 2 sine x cosine x. Well, now let's see. Suppose I want to solve this. Find sine of 3x. Just so we're all clear here, I cannot just pull the 3 out or do anything like that. It doesn't work with trig functions. Which means in order to find sine of 3x, I need to somehow write this x, well, just as x, not as 3x or 2x or anything. I can deal with sine of x, I can't deal with sine of 3x. So algebraically, I need to convert that to something with just an x in it. So what we can do is, we can kind of expand on this double angle formula. I can rewrite this as sine of 2x plus x. But now, well, let's see. According to the double angle formula, well, I guess before we move to the double angle formula, we use the sum angle formula. This becomes sine of 2x cosine of x plus cosine of 2x sine of x. And now we just took this, 2x plus x equals 3x, and we rewrote this using our sum angle formula for sine of x plus y. But now that I have that, now expand on that. And I'll change colors here and try to use multiple colors so you can kind of keep track of all the algebra at home. Sine of 2x, well, I can just apply the double angle formula to that. And we'll get, and here I'm going to need a lot of room. Make sure you have room on your paper if you're writing this down. Sine of 2x is 2 sine x cosine x. Then, that gets multiplied by cosine x. I did this in my seated class, so I'll do it for you too. I'm writing them in different colors so you can see each term. Plus cosine of 2x. That's the double angle formula for cosine. We didn't derive it. I said I wanted you to do it. But one of the forms, and the one we're going to use here, is cosine of 2x equals cosine squared x minus sine squared x. And then that, cosine of 2x equals this, that gets multiplied by sine x. So hopefully with the colors you can see everything that's going on. Sine of 2x became that. This cosine of x just carried along. This cosine of 2x became all of that. This sine x just carried along. Now it's just a matter of doing algebra to simplify things out. So first here, combine everything, multiplying. So we'll get 2 sine x, cosine x times cosine x is cosine squared x. Plus, here I have to distribute, I get cosine squared x sine x minus sine squared x times sine x is sine cubed x. And then let's see. 2 sine x cosine squared x plus cosine squared x sine x. Those are like terms they can combine. That's 3 cosine squared x sine x minus sine cubed x. And now that's completely fine, but for the sake of argument, just so we can do a little bit more algebra for practice, because you'll see this in your homework, maybe I want everything written just in terms of sine. Well, that's a sine, that's a sine, that's a cosine, can I get rid of it? Yeah, cosine squared of x, my Pythagorean identity, that becomes 1 minus sine squared. So I'm going to rearrange this a little. I'll just put the sine first. So it's 3 sine x. Cosine squared of x is 1 minus sine squared x. Minus the sine cubed x, which just carries along. Now distribute again. 3 sine x times 1 is 3 sine x. Then I get 3 sine x times negative sine squared x. That's minus 3 sine cubed x. Minus this sine cubed x that carried along. And then I get 3 sine x minus 3 sine cubed x minus sine cubed x. Those can be combined, and it's minus 4 sine cubed x. And now there we go. I took this sine of 3x, which seems pretty straightforward and simple. I just didn't like dealing with that 3x in there. And I rewrote it completely in terms of sine x. Yes, that's a sine cubed of x, but we would just find sine of x and then cube it, which isn't a big deal. And ultimately, again, I know this is a lot of algebra, but this is actually how we use these things. Admittedly, nowadays, I could just throw sine of 3x into a computer if I knew x, hit enter into a calculator and get an answer. But when we get to, say, Calc 1 and Calc 2 in particular, we have more complex problems that we can't necessarily solve by hand if there's something like a sine of 3x in there. So we need a trick like this algebraically to simplify the problem and get it down to something I can solve easier. So these identities, these formulas for double angles and sum angles, they are useful. I'm aware it can seem a little bit odd now, but we're kind of studying them now so that when we get to the more complex stuff later, we will have already had practice with this. There are several other formulas I want to go over, but I think I'm just going to cut this video now rather than trying to cram some other formulas in really, really quickly, and I'll just make several videos for different formulas.